Bismillahir Rahmanir Rahim. Assalamu alaikum wa rahmatullah. Peace and blessings upon you all. Dear students, we have read about a lot of things we did, and now it is time to go for predictive parsing. Okay, and the predictive parsing we can do it in many ways, and one of the first way, which is very simple, is the recursive descent parsing. And we know the predictive parsing actually constructs from top to down, and it never backtracks. And we know we have to first modify our grammar. We got to do elimination of left recursion and also perform the left factoring. We have done both of these guys. That's why we are unable to do now predictive parsing. Okay, a parser that uses actually set of recursive procedures. That's what we do in a recursive descent parsing. We have a recursive procedures to recognize inputs with no backtracking. We don't have backtracking here. It is actually the recursive descent parsing. It's actually also called, to note down, that it's called look before you leap strategy. Okay, so what do we actually here have in recursive descent parsing? Why we say recursive descent? Because we have here firstly the recursive procedures. We have here the procedures which we call recursively, and also we build from top to bottom, left to right, and that's why we call it a descent. So this is the recursive descent predictive parsing. Okay, let's take an example and see what's happening here. Basically what we do is we have the operation. What we do here is we have an input stream. Say for example, in an input stream we got something to read. For example, we got a plus a plus a. This is what we want to read from the input stream, and now we want to chuck it against our grammar rules, right? That actually describe the syntax of the input. So our recursive descent parser will look ahead one character. So that's why we look ahead one character, and then advance the input stream if that matches actually with our grammar, okay, or a production rule which tells us that syntax is correct. So we have a pointer here about the input stream, and we have some, because we have some production rules. Let's take an example of our production rules. The production rules are like this. We got capital A gives our A plus T, and T gives you some expression E, and sorry, A again, E gives you expression A back, this one, and then T gives you small a, the terminator. Now this is my grammar, and I want to actually derive the tree for this expression. Okay, so how we gonna do it? So firstly we start from the A. Definitely we start from the A, and we're gonna no choice to see A plus T is there because this is the left factored, so there are no confusions in taking up the production rules. Now we take up the A plus 2, and we already have the A in the bucket. That means we are having a pointer. Look ahead is on a A. We have a look ahead. Say we call that pointer as a next. Say for example, calls a next. Now next is pointing to A. Okay, so we have to match it. Yes, our A is matching with that A, so we move our next to plus. Okay, now that is again matching left to right. Okay, and now we move our next to having parentheses, so we have a parenthesis here, a starting parent in the next. Okay, that's a look ahead pointer. Now here we have the T now, so it is time to expand the T now. Okay, now if you could see, it could be expanded two ways. Either it can go to parent and A, and other it can go to A. Now which out of the two we take, because we are in a perfect position to decide which among the two we take, because the next look ahead pointer is pointing to the left parent. So the production rule which has the left parent will be chosen. Okay, so there is no confusions because we are looking ahead. So it's not like the backtracking stuff, because backtracking would have tried something out of two, and if it was not correct, it would have backtracked, it would have tried some other production rule, right? But here we actually have a pointer in pointing to a particular token which we need. So according to that, we choose out of the two which one, which production rule we have to choose. So this time here we have a left parent, and this contains a left parent, so there is no ambiguity, no confusion. We have to use this production, right? So what we have here is we try to expand the t now, because we are on a t now, and we try to expand the t, and it goes to like left parent, okay, then capital A, okay, and right parent. Now we are here, right, and our next is also here. So let me change my pen now. Let me change it to the red so that we understand properly. Our next is pointing to this left parent, and this is matching now, right? This is matching. So when the match is there, we actually do what? We go for the next input, okay? We increment the pointer and go to the next in a stream of inputs. So now it is an A, okay, and then now here is a non-terminator, and we have to actually expand it. Now A here does not have a choice, it is A plus T, okay, but we could have many here, but we don't have any confusions, because we will choose that production only according to our this next look ahead pointer, right, okay, which has an A in it. Right now we have only one choice for A, so because A plus T, we will do it. So we're gonna expand it here. So here we're gonna expand it A plus and T, okay. Now when this is expanded, we are here, right, okay. Now our look ahead next pointer is pointing to the A, and we have an A, so this is a match. So if it is a match, we will actually do what? We will increment our pointer, so it goes to the plus, okay. Now pointer is here, right, add to plus, and we increment this side also, we have a plus, so this is a match, so we go here, okay, and we increment this pointer also, so we are at the A, okay, we are at the A. Now our look ahead next pointer is pointing to the A, and we have a T, and now we have to expand the T. Now which production rule we'll use, there will be no confusion, as our production rules here out of these two, this one contains the left parent and this one contains the A, so this is a exact guy which we should use, so definitely we should use the A, okay. This is a terminator, so when the terminator is there, we try to match it with the next pointer, which is pointing to the input stream, and it is A, it's matching, so we move forward, and now this is matched, so we go here, this is also matched with my right parent, okay, and that's it, our input is done. So this is how we build our recursive descent predictive parser. Why is it predictive? Because there is no backtracking. Why is predictive? Because our next pointer actually predicts which production rule we have to use, okay. That's why we don't have any backtracking here, and but for that we need to have our grammar left factored, and also there should be no left recursions, okay, and then only then we can this recursive descent predictive parsing will work, okay. Isn't it very simple? And it's much faster than the backtrack, because in backtracking you have to try one production rule, then if it doesn't work, you have to retreat, you have to come back, backtrack, and use some other production rule. If that doesn't work, then other, and so on. So that will be a really hectic thing, but here we have done in a much better way, even though we have a much better algorithms which will come which we will see the next after this, but this is also a nice and easy one. So how we do all these things is by the procedures, right? So we're gonna have some procedures which will help us. So what we were doing, if we try to think about it, is we try to scan the input. This is the input stream, okay. From the input stream, these are the tokens given the lexicon analyzer, right? So we take up the tokens in some look ahead pointer which points to them, and according to that we try to use a production rule, isn't it? So what we do is we have a procedures for these production rules, and we have a firstly procedure which actually matches these two. Let us call that as a match. Let me call that procedure as a match. So let us call that procedure as a match, okay. Let me call that as a match. This is my match procedure, which takes two inputs. One is the input symbol, okay, and one is that next, and this guy actually returns me what it returns is a boolean, okay. It returns true or false, Okay, we should understand that it should return either true or false. If the match is there, it returns true. If the match is not, it returns false. Do you understand? So what is this input? Input is the input sorry, what I was saying is we have here the input and the next. What input does is input actually has a terminal symbol in the grammar, or in this parse tree we can say, and next we'll have what we want, that is from the input stream. Okay, the next is pointing to the input stream, and the symbol, actually this input will take up the things from the parse tree which we have built so far. Say for example, a goes to a plus t. Now symbol will have this a. Okay, now then symbol will have plus, then symbol will have t, and so on. Okay, now what we have to do in a match is we got to match a. If this input is now in the input is a, for example, and this is to be matched with the what is in the next. Next will always point to the next. When it has done it, next will point to the next actually. Okay, so it is look that's what we call it, a look ahead. Now so what else we do in this match procedure is, so how are we gonna do it? We will actually simply see here there will be some kind of if block. You can use in any language you like. I'm just using simple general things. If I say this input, whatever the input is at that moment, when I call it, is equal to next. Okay, when this is, they are equal. Okay, then what we're gonna do, we will advance our input stream pointer. Okay, so what I'm gonna say is next is equal to, either if you use say C++ or C, you say maybe get character, get char, or that will actually take next character from the input, or you may say you may use scanner if you are using the Java or something. But what I want to do is here is just try to make you understand the next will point to the next character from the input. Okay, that's actually the tokens, the next token. Okay, now if this is true, we will also make some variable. Say I will say it m as true. Okay, else m equals to false. If if the match occurs, I will make it true. Okay, if this happened, I will do one first thing I will do is I will go to the next character because the match has occurred, and I will make m true and I'm gonna return it, or I will make m as false, and in both cases I will return my m. So that is actually the true or false. So match will tell me if the match has occurred or not. This procedure will tell me if the match has occurred or not. Say for example, in the first instance, the next was having a, and the input was also having a. Now I will call the match is a and a matched. If yes, okay, I have to do nothing. Then I have to go forward. I will make my next to point to the next input, that is here. Now next will point to the plus. Okay, and also we will go for this plus. Okay, but in this case in this case I'm only incrementing my read pointer. Okay, this look ahead next pointer. Okay, now this thing will be done in another procedure which try to build actually this parse tree. Okay, so how we actually this recursive descent parse actually do what? It traverses the tree by first calling a procedure which recognize this a. Okay, so we have a procedure for this a, definitely, because a is there, which reads, okay, a and plus, and then calls the t procedure. Okay, it calls the procedure which recognizes the t. Okay, so it will be like this. Before doing this, let us think a little bit, because we have to because our grammars is like this. So where the start symbol is a, so we need to have a procedure a. Okay, now which has a plus t. So that means the a has to have a and then plus, and then it should call for some procedure t. Okay, so t is another procedure, because for every non-terminal we have a procedure. That is why it is called recursive descent, because we have a recursive procedures which we call all the time, these procedures for all non-terminals. And terminals, we go for the matching with the next pointer. Okay, so in the first case we will have an a, so which will try to see if a and plus is there matched or not, then it go for t, right? So this is what we do. So that means we're gonna have a procedure a, so we're gonna have a procedure called a, right? And when we call it, we pass it that next. Okay, the first case it was an a, right? In the next was pointing to the a, because we had a string a plus a, and next is pointing to this a, right? Now so this next is having a. So inside what we have a simple if. We say if there is a match, and we send what to the match, a, okay, the character a, comma, and I send it the next, whatever the next is, and I'm using the logical and. That means if both are true, I will do it here, match of what is there, plus, okay, and the next. If this is so, if this is true, if both are true, a is there, plus is there, then what I do is we will inside call a procedure t. We will call the t. Okay, we will call the t method. Does it make sense? We call a t, the t is itself a procedure, right? We call the t, and we're going to return. If this doesn't happen, else we do some error handling, right? We call a method called error handler, which will tell us, hey buddy, the syntax is not correct. Okay, now let us see this thing first. Now look here, in the first case, I'm saying that I have sent it the a in the next. Okay, so next is having a this time. Okay, and now I say match. I call the match function and I send this a, and next is also a to the match. So what will happen in the match? So here in the match, input is having a, right, this time, and next is also having a. So that therefore there is a match. Input equals to next. What will next do? Next will go to the next character. So next now will have a plus in it. Okay, next it will have a plus in it, and we return the true. So we return true from this. So this guy will return true. So it has done two things. It has returned the true, and also the next now has a plus. So we try to end it with the match. Again we call the match, but this time around we send the plus. Now plus will go into the input, so input will have a plus, and we know in next is also pointing to the plus, is it? So now we input is equal to next. I will say yes, it is. So we try to go to, we next moves to the next character, that is now the left parent. Okay, now next will have left parent in it. Change the pen. The next is pointing to the left parent. Next will have a left parent in it now. Okay, and it has returned the true. Now this has also returned true. So this is true, this is also true, and the next is now pointing to the left starting parent, right? So this is true. Okay, so we call the t, a procedure t, right? Because now we have to expand the t. Now we'll expand the t, right? So we're gonna call the procedure t. So we'll have another procedure, that is the t. So error handling, and it will return, because error handling doesn't work here, because we have our this a procedure a worked fine. So we got plus a and plus in our input stream, so that is according to the grammar. So we now have to expand the t. So we, for t also, we will have a procedure, right? So this is my t. So before we do the t, we should little bit think, and what should the t do? Now because t has two procedures to call, that depends on the next. If the next has the left parent, okay, then it has to do this production. If it does not have a left parent, then it has to do this production. So we have to match it with the left parent, and we will match it with the A, right? So that's what we do here, and it's a little bit we have to do more to understand. So this is my the T. In the T, I will also send the next, because on the base of next, this look ahead pointer, I have to decide which production rule. So that's not a difficult to do. We say if, and we call the match, okay, and in the match we send the left parent, and with the next, if left parent and next match, okay, we actually call the procedure A again. Okay, now this is one thing. Then I will say if this should be here like this, okay, if match right parent, okay, we will try to discuss it, but let me write it first. With the next, then you should simply return, okay, then you should return. And if they don't work, if we have a match with the A input with the next, okay, then what we should do is we should again return. Else, if nothing happens, we should do what? We should do error handling. Okay, call the procedure which is error handling, or whatever you like. Now what does that mean? Look here, where were we firstly? So we are here, right? So our next has the opening parent in it, right? We have an open parent in our next, and we call the T. What will T do? T will try to call the match, because in the next, what we have in the next is the opening parent. Okay, keep that thing in mind. Now we call the inside the T, we're calling the match again. Okay, so when we call the match, we send it opening parent, and the next, we know next has the opening parent in it, so it's gonna match. But what will it do is it will when will you call the match actually try to see input and next. It sees yes, input is left parent, next is also left parent, but it goes to the next character. So now we are at the A, okay, and it gets true back. Now here in here it gets true back. So if this is true, yes, it is true in this time, so it will call the A. Okay, now when it call the A, what will A do is it will again call the match, and it will try to check with A and plus. Firstly, to check with the A, and we know next is this time pointing to the A, right? Next is pointing to the A here, right? So the match will match it. Okay, match does what? It matches A, because next is also A, so it comes true, and it increments the next to the plus. Now match will point to the plus, the input will point to the plus. I'm sorry, next will point to the plus. Okay, and here plus from the input is matched to the next, that is plus. So this is again a true, but it will the match procedure will increment the next, so that will point to the A. So they both come to the true, and A again calls T. So we have called A from the T. Now A inside calls the T again. Okay, when we had in the next we have the A. Okay, now what will happen? So when it calls the T, this guy, if it tries to call the match with the left parent, the match will return false, because left parent is not in the, what is the match? Here is the match. Left parent is not in the next, because input and next will not match. It will return the false. So this is not gonna work, this is not gonna work, and this is gonna work, because next and A will match. So match, when this if will work at this time, match has here in the next we have A, and sorry, match is, where is match? This one. Input is A, next is 8, so it will return true and increments the next here to the next input, that is the right parent, and it comes back here. Okay, so it comes back here. So when it comes back, it returns back. Okay, and now it will return. Now it will return to the calling program. Who has called it? This is the T called from here, right? So it comes back here, so it returns. So who has this A called? A was called from the T. Okay, so it comes back here. Okay, and from here now this is done. Okay, so it will try this if again. So now this if has a match of it will call the match with the closing parent, and this because next has the closing parent right now, so this closing parent and this closing parent will match, so it will return, and our input goes further because it's the end of the file, so we are done. So it gets back out of this T and it goes where it was called first, so it was called in the A first, right? And it returns back and we are done. So what will happen is if there was never error handler called, our program actually successfully ended. But that means our input stream is syntactically correct, it's according to the grammar, right? Okay, here if you are confused, you should understand that we had an procedure. Let me write it here, because we have an internal stack for this, which will actually take care of these recursive procedure calls, because we had an A, right? Okay, here we run first the A. In the A we had a max and all, then we call the T. Okay, and T, when you call the T itself calls the A. So that means when we call the T from the A, we were here, that means after this line is yet to be done, but we have jumped from T to here, and from here we are, say for example, line number 1, line number 2. On line number 2 we call the A, so after that it is still to be done, right? And we call the A. Now inside the T we call the A, inside A we call T, and rest of the A is still to be done. Inside T we call A, rest of the T is still to be done. Okay, here. And then when we call the A, we did our procedures and all. Okay, and we call the T again for the right parent. Okay, then when we are done with the T, it finishes, it goes back to the A and starts doing whatever left was in the A, and then it goes back to the T, whatever left was in the T, and then it goes back to the A, but it was left in the A. Try to do that. Okay, you just try out these things on a copy, and this is simpler, and you must have no knowledge of the recursive calls from any programming language, and that will help. If you are not understanding well, so you can comment it, so I will try to answer that also. Okay, so what will be the main function of it? If we talk about the main function, this is main and whatever and so on. The first thing will be to get into the next, because whatever we do is we first either call the get char or use kind of method or whatever method you use according to the language. Okay, now this is the look ahead, because we upfront get one first character into the next. Okay, and the next can be the pointer or whatever it is, or it may be just a variable which holds the that first input token. Now that is the implementation details. That is how that will depend on the programming language you'll be using. And what is the first job after that will be to call the A method, right, and pass the next to it, right? So we call the A. If you see here, you call the A and you are sending it the next. Okay, whenever you call the A, you have to send the next to it, and here also I'm calling the A, so at that moment you have to send the next to it, which I forgot, because that is you have to do according to whatever the method is and all that. I'm not showing exactly in a programming language construct. I'm just trying to, I'm not concentrating on the programming language constructs, right? So it will become a little complicated to explain because you already know all these things. So I'm just putting up the things together. So this you call the A, okay? And if you come back from here, the error handlings may exit the program by itself with giving a proper message. So here, or you may do other thing that you have an when the end of file, if next is EOF end of file, that means we have scanned fully. So you can one implementation is like if next is equal to end of file, right? So that means we have done properly. We have scanned full string. So that's only possible when we are done perfectly, so we don't have any errors. So then you can say message success message here, okay? Or error handling will do itself. If there is an error, error handling will exit from there only, not from here, right? Because if error handling returns the control to the main, then that means we're going to go to the else part, and where we say some error message, okay? Or error handler will do it of its own, and we don't even worry about this. If it comes here, that means we are a success, okay? So this will be the main. One more implementation detail is we can have these things as an object itself, okay? Then if we use the Java or C++, which is object oriented, then everything will be like objects, okay? And your get, this will not be like get character. This will be like we may have a method in our lexer. We will say lexer.get, where from we get the token, okay? We get the token from the lexical analyzer. So we call the lexer.get method to get a new token and put that into the next. So implementation details, implementation can be different. That is your choice, what you're gonna do. But the main concept is gonna be the same. Now I think that's all for this recursive descent parsing. And if you're not understanding properly, you gotta watch this a couple of times or more times. And the next is why we use LLK parsing. Now what is this LLK parsing and how we improve that also will be our next video. So until then, ma salama.